All right, here we are in our third video for lesson 9. Number 4, we're now on page 78 in your book. And our questions have been, what do we notice that's different about this problem? And what do we notice that's the same about other problems we've done? Here we have 3 add-ins, 3 numbers added together. So, what strategies should we use? What are we going to do when we have 3 numbers? We have to think about this. Could listing our multiples for skips counting, is that going to work? And do we have to do all 3? 12, 20, and 4. We can think about those numbers as well. Okay, maybe make some notes there of what you could do. And I have some student work to show you. So let's check this out. Okay, here's how one student did it. You can see that he wrote down 5/20, 3/12, and 3/4. Then he multiplied 5/20 by 3, and 3/12 by 5, and 3/4 by 15 to find the common denominator of 60. All right, so here we have 15/60ths, 15/60ths, and 45/60ths adding together to make 75. Can you imagine that what he did there, right? He was thinking of multiples of 20, multiples of 12, right? 12 times 5 is 60. And then multiples of 4 all the way to 15. So, I mean, some of you know your 15s, so that's good, but that might have been a little challenging, right, to change them all to 60ths, but yes, had to change them all to the same denominator to add them together. All right, let's look how another student did it. Okay, here is fictional student Kayla. She divided. Yeah. So she divided 20 by 5 to get fourths, divided 12 by 3 to get fourths, and kept the fourths the same. So she noticed that you could divide both of these to get fourths, and then added them together to get 5/4, which would be the same as 1 and 1/4 if you're worried about this improper fraction here, right? Now that is pretty efficient, but you do have to know that you can divide to get fourths there, right? Very nice. Now let's check out this one. This one, look at the huge number, 112 960ths. Whoa. Because this person said, well, I'm going to multiply them all by each other. So times 12ths times fourths. See that? And then 12ths times 20ths times fourths, and then fourths times 20ths times 12ths. So actually multiplied 12 times 20 to get 120, and then times 4 to get 480, or 960. Yeah, 960. And did the same thing to the top. Wow, that is a huge number. So this is what I was saying about multiplying each number by itself might be a little too much, right? And if you have questions about this model of the division, right? This really helps if you know your multiplication tables and you can see those relationships, which you're learning more and more as you go, right? Okay, but I just wanted to point out that multiplying by each other is not always the most efficient strategy, right? Okay, we have another thing to look at here. Oh, there it is again, that one, right? Okay, and then we have number 5, another one with 3 add-ins. And this is actually the one with Ames from the problem that we did in class, from the 9 loaves of bread sharing among 10 people all the way back in ancient Egypt, right? And he had 2/3 plus 1/5 plus 1/30. Now let's think about that. Another one with 3 thirds, fifths, and 30ths. I I can't change my thirds and my fifths, but I could multiply these two together and make 15, right? Because 3 times 5 is 15 and 5 times 3 is 15. Could I change my 30ths to 15ths? I could divide it in half. Oh, but I can't divide 1 in half. So I think I have to change them all to 30ths. 2/3 times what equals 30ths? 10, yeah. So that would be 20/30ths. And 1/5 times what equals 30ths? Times 6. 6 times 5 is 30. So 1 times 6 is 6. And 1/30 is already 30ths. And then I just need to add them all together. 26 27/30ths. 27/30ths. Now we said in class that if we were going to divide 9 loaves of bread by 10 people, that would be 9/10ths, right? That would be 9/10ths. Is this also 9/10ths? If I divide them both by 3, right? 30 divided by what is 10? 30 divided by 3 is 10. 27 divided by 3 is 9. Very good. And it does come out to 9/10ths. So perfectly nice. Yes. Make sure you have that written down for number 5. And we have one more problem to look at. Okay. 2/9 minus 2/6. How can we make like units for this? And why? Ninths and sixths. Think about that. Okay, here's a student's work. Maybe. There we go. There's Scott's work. What do you notice about Scott's work? And what do you wonder? Do you notice that he kept the 12/9 the same? And then he changed 2/6 to 3/9. Are you wondering how he changed 2/6 to 3/9? Yeah, so am I. I see that he made like units, right? The steps that he took. And he subtracted 12 minus 3 is 9. Okay. So why does he think that 2/6 and 3/9 are equivalent fractions? Where do you see flexible thinking in his work? Maybe he's thinking about 2/6. If I divide those both by 2, then I'm going to have 1/3. And 3/9, if I divide those both by 3, I'm going to have 1/3. Ooh, that is interesting, isn't it? So he was able to rename 2/6 as 3/9 because they're both equal to 1/3. So he didn't multiply 6 times something to get ninths, but he was able to rename it thinking about maybe an area model of 1/3, right? If I cut it in 1 time, it's 2/6. And if I cut it 2 times, it's 3/9, right? What would Scott's work look like if he multiplied 6 times 9 to find a common denominator? Well, that would be 50/4, right? So that would be a lot more of big numbers to work with. That's very flexible what Scott did there, right? It's more efficient, and it would be helpful to think about in another way, but that's like pretty high level. So if you don't quite get it, it's okay. You can come and talk to me about it. But this is some very flexible thinking in math. Very nice job. All right. Thanks for your kind attention. And I'll see you on the next video for lesson 10. Aloha.